Diac. Diac is a bidirectional device. That means the current flows in the diac in both directions. That's why we can say that diac can conduct in both directions. But it cannot require any gate pulse, any gate voltage or any gate current for this operation. Now due to this reason, diac is known as a bidirectional trigger diode. Let me see the construction. When three semiconducting layers alternately, two p-type and one n-types are kept one over another. Due to this layer, that means the n layer is placed on the p-type material and another p-type material is placed on the n-type layer. So now due to these three layers, two junctions are formed. One junction 1 J1 occurs between first p-type material or p-type layer and the n-type layer, and another junction J2 occurs between n-type layer and another p2 type layer. So now the doping concentration in the both junctions are same. So due to this, we will get same characteristics in the both direction. So there are two terminals are taken out from these devices. One terminal is taken out from the first p-type layer and another terminal taken out from the another p-type layer. So due to this, we can say that Diac is a three-layer, two-junction, two-terminal devices. So generally, these two terminal is denoted by MT. Sometimes we are using MT1 as well as MT2. Some books they are using T1, T2. So now when the upper terminal, that means MT1 terminal, is positive with respect to lower terminal, we can say that this MT2 terminal or lower terminal, the junction J1 between P1 and N becomes forward bias, and junction J2 between N and P2 is reverse bias. Now when the avalanche occurs at this junction J2, it is between P2 and N, when the applied voltage to the diode is greater than its breakover voltage. So due to this, the whole structure comes into conduction mode and the current flow from terminal MT1 to MT2, or you can say that it flow from T1 to T2, or its flow from the upper terminal to lower terminal. Now similarly, the lower terminal MT2, T2 or T2 is a positive with respect to the upper terminal MT1. So that time this junction J1, which is between P1 and N, is reverse bias, and the another junction J2 between N and P2 is reverse bias. So now when the applied voltage to the reverse voltage applied to this diode is greater than its breakdown voltage, the avalanche breakdown occurs at this junction J1 because it is reverse bias. So avalanche breakdown is occur. So the whole structure becomes in conduction mode and the current flow from terminal MT2 to MT1 or T2 to T1 or from lower to upper. Now let me see the characteristics of the diode. So as shown in this figure, it is a VI characteristics of the diode, which is between the current passing through this diode and the voltage applied to the diode. So now here VB01, that means we can say the plus VBO, and here this is the VBO2, that means minus VBO. It is the range of breakover voltage. So when the applied voltage to the diode, the value of applied voltage to the diode is less than its breakover voltage, that time this diode offers very high resistance. Very high resistance. That means when let me see, when the positive voltage is applied to this diode and its value is less than its breakover voltage, that time a very small amount of current passing through the diode. Here you can see, and it is called leakage current. Now similarly, the value of negative voltage is applied to the diode is less than its breakdown voltage, or a very small amount of current passing through this diode is called leakage current. So as you can see, the OA, it is a region, and this region is known as a blocking region. Now during this period or blocking this period, the diode acts as a open circuit. Now the diode is designed for the 30 to 35 volt breakdown voltage of 30 to 35 volt in both directions. That means it's required 30 to 35 volt to turn on the diode in the both direction. Now when the value of positive or negative voltage applied to the diode is greater than its breakdown voltage, a diode comes into conduction mode, and very less amount of voltage drop occurs in the devices. So the region AB, as you can see this figure, this AB region is known as a conduction mode. AB you can see there. Now the value of current passing through this diode is less than its holding value, or you can say that the value of current passing through this diode is greater than its holding current. The diode remains in conduction mode. So you can see, as shown in figure, the value of breakover voltage and holding current in forward bias and reverse bias is same. Once your thyristor, your diode is turned on, the current passing through this diode is increasing. So here you can see that the characteristics for positive half cycle and negative half cycles remains same because the concentration doping in the junctions are same. So already I told you. What are the application of triode? So triode is mostly used for the firing of SCR and the triode.